students. I'm Jalisha, Assistant Professor, Department of Mathematics, St. Joseph's College of Arts and Science, Government Hosur. Today we are going to see about the functions in discrete mathematics. Functions. Functions means it is a relation between any two sets. So relation is already explained in the previous video. So based on the relation, how we are going to define a function. A function is a special type of relation. It may be considered as a relation in which each element of the domain belongs to only one ordered pair in the relation. So for every element will map to only one element in the relation. Thus, a function from A to B is a subset of A cross B. A cross B means if the relation exists between A and B, then the elements of those two can be expressed in the ordered pair. So, if we are able to describe the elements in an ordered pair form means then those parental set can be joined in the form as cross product, that is A cross B, having the property that for each element A belongs to capital A, there is only one element B in capital B set such that the ordered pair A, B will be in G, that is the group. It can also be defined as if A and B be any two sets, then the relation from A to B is called a function. Now we are going to say the relation into a function if for every A belongs to capital A, there is a unique B in the set B such that the ordered pair AB belongs to the function. If A in capital A, then the unique element of B assigned to an under F is denoted by F of A. What is explained there means if we are considering an element A in capital A, then the assigned element answer for A in capital B can be represented as F of A. The usual notation for a function f from A to B is f colon A tends to B, defined by f of A where A will be from capital A. Here f of A is called as the image under the function f and A is called as the pre-image. So that I'll explain in the next upcoming slide. Okay. Now we are going to see about the types of function. First one is one-to-one function. It is also called as injective. A mapping f from A to B is called one-to-one or otherwise called as injective if distinct elements of A are mapped into distinct elements of B. So for each element A, it should be mapped to different answers. That is called as one-to-one mapping. That is, its condition is if f is 1 to 1, if you are considering any two elements a1 is equal to a2. Two elements are considered from the domain set. Domain means in this function, the starting set A is called as the domain and where the answers will end, that is called as the range set. So here from domain A, we are considering two elements a1 and a2. If those two elements are equal means then its image. Image means when f is applied for the elements of A, it will go to the set B as answer. That answer values are called as image. So A1 equal to A2, we'll get f of A1 equal to f of A2. If this condition is satisfied means it is called as one-to-one. Next type is onto. A function f from A to B is called onto, otherwise it is called as surjective. If for every element B in the set capital B, there is an element A in capital A such that f of A will be equal to B. That is, in one-to-one and in the normal mapping form, we will say for element from A, it should map to an element in B. Whereas onto means we need to check the elements from B. So from B, each element is mapped to A means, so B to A, you'll get the pre-image. A to B is image, B to A is called as pre-image. So for every element of B, if there exists a pre-image in A, then it is called as onto function. If both one-to-one and onto is satisfied in a function, then that function is called as bijective. So here I have given some examples of functions. The first one, look at here, four elements in the domain and three in the codomain, that is range set. Here A is mapped to 2, B to 3, C to 1. So can we say this as a function means what is the definition of a function? All the elements in the domain should map at least one element in the codomain. So A is mapped, B is mapped, C is mapped, but D is not in the mapping. Hence, we cannot say this as a function. So the first one is not a function. Now coming with the second one. A is mapped to, C is mapped to 1 and B is mapped to 2. So all the elements in the domain set is mapped to any one element in the codomain. So can we say this as a function means yes, this is a function. But now check here, in the range one element is not mapped. In the previous slide I have explained for onto function if we need to check the elements from the codomain. So for this codomain, for the element 3, there is no mapping. So this is a function but not onto. Now can we say this as one to one? One to one means if A is different from B, then its image should also be different. So here A and B are different. So A is mapped to 2, B is also mapped to 2. So two different elements mapped to the same element means it can be a function but not one to one. Okay. Now we can move with the next example. Here I have given two elements in the domain and two elements in the codomain. A is mapped to 2, A is also mapped to 1, B is mapped to 1. Okay, B is mapped to 1 is not an issue. But here A, if we are considering this as a question set means for this question you are having two different answers. So which thing you are going to accept or take? This is the question. So always the domain should be a well-defined one. Well-defined means we should able to give either the answer as true or false in discrete mathematics. But here A takes 1 and also it takes 2. So we are not able to define it properly. Hence, this is not a function. And in the next example, see here A is mapped to 2, B is mapped to C, 1, C is also mapped to 1. So all the elements in the domain are mapped to any one element here. So this is a function. And also reversely you check in the pre-image. For 1 the pre-image is B and C, for 2 the pre-image is A. Hence, you can say this is on to, but one to one is not possible because B and C are different, but they are having, so answer should also be different. But here it is having the same answer 1. So this is also not possible. So this function is not one to one. Coming with the last, but here we can't say this is onto because for onto in the reverse order we need to check. So here one is having both B and C as answer. So which thing we can finalize, that is the question here. So all the elements in the codomain are mapped, but for element 1 it is not having an unique answer. So if we are considering the sets here A, B, C, 1, 2. So A is mapped to B to 1, Now check here in the last one, this is on to, and here three elements in the domain, three elements in the codomain. A is mapped to 2, B is mapped to 3, and C to 1. So here all the different elements having different answers in the codomain. Hence different element is having different answers. Both the sides, all the elements are having image and pre-image. That is from domain means it is having image. From codomain means it is having the pre-image. So this function you can say it as 1 to 1. These are the things how we can able to clarify the given mapping as a function and which type of function it is. So next is composition of functions. So two functions we need to consider. The first function here it is f from a to b, and the second function is b to c. If the function is of this order, that is first function a to b, and the next is starting from b, that is b to c, then only we'll be able to join these two functions to form a composition. Otherwise it is not able. Suppose it is from c to b, here means we are not able to combine these two functions to get the composition values. So we need to check into this condition. If the two functions are given this form, then we can have a composition of function among these two, that is g dot f. So why we are giving here a g dot f means always in the composition, first we'll apply the right side value and next to the left. So here first f means that should be in the right side of dot, and next is g means left side of dot we need to take. So here then only we will be able to g dot f is from, first we need to give f. So f is from a to b, then g is from b to c. So combining this, you'll get g dot f as b to c. So that is what given here. Sorry, a to c. So g dot f is from a to c and is given by g dot f is equal to, from where it takes the domain, g dot f is from a to c. So it takes the elements from capital A, and the function g dot f is applied for that element, you'll get the answer in C. So which ordered pair you'll get? A comma C. So only we have defined here the set g dot f is equal to set of all ordered pair AC, where A is taken from the set A and C is taken from the set C. Here I have given an example for the composite function. So the sets are described here. A is equal to 1, 2, 3 elements. B is AB and C is XY. Now we are defining the function f from A to B as f of, here which is the domain A. So the function will give the answers for the values in A, that is f of 1, f of 2 and f of 3. It is defined here, and it will give the answer in which set? B. So f of 1, f of 2, f of 3 will takes the answers from the set B. That is either A or B. So based on that they have given the values of f of 1, 2 and 3. Next, the function is g from b to c. It is defined as g of a is equal to x and g of b equal to y. Again, g is starting from the set B. Its elements are a and b. The function will give the elements for g of a and g of b. It takes the elements, it gives the answer in C, that is either x or y as the answer. So from this defined thing, we can say F is an ordered pair, which is the domain 1, which is the codomain A. So how you can write this in ordered pair? 1 comma A. So F is equal to, first pair is 1 comma A, second pair is 2 comma B, third pair is 3 comma B. That is given here. Next for G, which is the pair here, A with respect to X. So A is related to X means A comma X. B is related to Y means B comma Y. It is given here. Now we need to find the value of G dot F. We know it is from A to C. So G dot F, its domain is A. So G dot F will defines the value, that is starts the value for 1, 2, 3. So g dot f of 1 we need to give, g dot f of 2, g dot f of 3. For these three values, we need to give the answers. G dot f of 1, that is g of f of 1, because first we need to solve f of 1. For that answer, we need to apply the g. Okay, f of 1, what is the answer? It is a. So we have applied in the place of f of 1 a. Now g of a, what is the value of g of a? It is x. So finally we get g dot f of 1 is equal to x. So for this composite function, the first ordered pair is 1 is related to x. So 1 comma x. Likewise, we are finding g dot f of 2, g dot f of 3. So here are some practice questions. Go through with it. Thank you for listening.